Hello and welcome to the Maths of Music. I am Nicholas Brusby. I am a member of the IMA. I work as an engineer at Rolls-Royce PLC doing stress analysis, but I am also a musician. See the pictures of me there? That is me with some friends at Derby Concert Band when we went to the National Concert Band Festival a few years ago and thankfully won gold. Big shout out to everyone at Derby Concert Band, and please look at their Facebook page for their latest updates on distance banding videos where we've been trying to play some music for you all whilst we aren't able to do concerts or rehearse. Now, the question is though, what am I going to talk about? Well, full disclaimer, I am not a professional acoustic engineer or really anyone who's got any background in acoustics other than the fact that my background is a mathematics degree. I am indeed a mathematician. I've done my undergraduate at the University of Manchester in mathematics and then my postgraduate again at the University of Manchester in applied mathematics, focusing on industrial modelling. As I said, full disclaimer, I am not an expert in this and I'm an applied mathematician who works as an engineer. So in the great words of Tyrion Lannister, if you're looking for rigorous mathematics, you've come to the wrong place. Here we're going to try and have a little bit of fun and also try and learn something. So the big question is, what are we going to do over the next few weeks?
This series is going to contain 5 episodes. This episode, episode 1, is going to answer the question, what is music, and provide a mathematical definition and representation of what music is. Episode 2 is going to answer the question, what are sound waves and how do they propagate through air? Because ultimately, music is just sound waves. Episode 3 is going to answer the question, what sound waves correspond to the notes of the scale? Why do some sounds sound good together and why do some notes sound bad together? As well as look at the concepts of timbre and tuning. Finally, Episode 4 and 5, they're going to look at how instruments make sound. Episode 4 looking at string instruments and episode 5 at wind instruments.
Right, now the big question is, what is music? That's what I'm aiming to answer today, and how can we represent that mathematically? Well, ultimately, music is so open to interpretation. Now, you can ask different people different things and they'll say different answers. But I'm going to give the following definition about what music is and then go to the keyboard to demonstrate it for you.
So, what is music? Well, in the words of Bernie Sanders here, music is just wiggly air, which ultimately does capture the essence of what music is. But it's not particularly helpful. So let's have a look at what the Oxford English Dictionary says about music. Music, vocal or instrumental sounds, or both, combined in such a way as to produce beauty of form, harmony, and expression of emotion. Now, that again, it's quite descriptive. I'd say that does hit the nail on the head with what music is, but it's not very useful mathematically. So I'm going to take this a little bit further and give us a mathematical definition of what music is. Music is a sequence of sounds.
So, we now have a definition of what music is. Music is a sequence of sounds. So, does that mean that any sequence of sound forms music? Well, surely this is a matter of personal opinion and personal perception. So, is the following music? Or how about this? I personally don't think either of those two sounds form music by themselves. But what if I was to do this to them and give them a set sequence? Yes, we now have something which is very reminiscent of a famous rock song by a very famous rock band. Now, this here, you can argue, therefore, we now have some form of music. The sequence has created music. Obviously, what sequences create music can vary greatly depending on your personal opinion. For example, when I lived at university, I had housemates who were music students, and in their final year composition they did atonal music, which basically took a lot of different sounds and put them in a sequence to create music that they called music. I went to their final year recitals and left going a bit like, what on earth have I just listened to? Because to me it just seemed like a lot of random noise, but apparently it was good music. So this is a demonstration of why perception does matter. But for me, this idea that any sound can be music is a little bit too open to interpretation. Mathematicians, we like definitions, we like restricting things and giving ourselves a nice, well-defined space to work in. So, I'm going to take my definition one step further.
Music is a sequence of sounds where each sound comes from a prescribed set of permissible sounds which we shall call the key signature.
Yes, now I've defined a key signature. I've restricted the sounds I can make and use to something in a key signature. So this is a set of sounds which can combine via a sequence. So what's the simplest key signature? Well, in Western music, which is what I'm most familiar with, the simplest key signature is the key of C major, which is all the white notes on the keyboard. So, was that music? Well, we've all heard piano slide, we've heard trombone slides before, but essentially we have all these white notes. I could play the same notes on the clarinet, for example, on the saxophone here, and I've restricted my notes that I can play into this key signature, but now does any sequence, now we've restricted our key and the sound we can make, does any sequence make music? Little bit maybe, not very much. So again, the sequence is still very important to decide what you personally interpret as music. So what about this sequence? Does that sound like a nice bit of music, a nice melody? Well, I think it does. That's reasonable. But there's something missing. We don't all hear music which is just a single line that goes. There's more to it. There's backing. There's extra bits in there. There's chords. So, how can we represent them mathematically? So again, I'm now going to have to extend my definition.
Music is a sequence of vectors where the entries of each vector are sounds which come from a permissible set of sounds called the key signature.
Okay, so there we go. We now have a mathematical way of expressing playing multiple notes at once via these vectors. So if the entries of a vector are notes, the simplest vector that one can play is the vector of C major, which is the notes C, E and G. There we go. Now, this sequence of vectors is what will now allow us to build up more complicated sounds. These harmonies, these backing chords, these melody lines, they all come together in this very complex sequence of potentially very long vectors. I mean, think about an orchestra with all those hundreds of instruments there, each playing, similar lines, different notes, similar notes, harmonies, and you could prescribe an entry of each vector for each instrument and what it needs to do at each point in time. And then just the vector sequence as it changes is what gives you your music. An example of this is, remember our melody? Let's add in some chords to that. See, we have a sequence of vectors there playing multiple notes, and that gives us something a little bit more reminiscent of what we're used to when we talk about music. Now, the key thing here is that obviously that's a very simple piece of music, and as I've said, orchestras, bands, singers, backing vocalists, all these things, they're very complex layers of music, and you would have much more complex vectoral sequences than what I've just played for you there. However, we now have some sort of mathematical structure, and all the sequence would say is play this vector for this amount of time, play this vector for this amount of time. So there we go, we have some structure there which we can follow mathematically and a representation of what music is. But obviously there's so many more questions that are now there to be answered, some of which I've mentioned already. So we've got, what is sound? What is sound? Well, sound is a sound wave. It's a superposition of various sound waves. And over the course of next episode, I'll explain what a sound wave is and how it moves through air. Then we have, how do different notes combine? Episode 3, I'm going to focus on talking around how different chordal structures, how they give different notes and different sounds. Why do some sound good? Why do some sound bad? Why do some sequences sound good? Why do some sequences sound bad? And on top of that, also talking about, how do these individual notes combine to create the sound that we hear? Finally, the last 2 episodes, I'm going to talk about how do instruments make music? Because obviously we've all seen, this, and I could play something for you there and you'd hear the instrument make a sound. But how does it do that? Now, I'm going to focus in episode 4 talking about how string instruments make sound, and in episode 5 I'm going to talk about how wind instruments make sound. So hopefully that's plenty of it for us to be getting on at over the next few weeks, and I hope that you will all tune in and watch these, and hopefully we can all learn something and have some fun. Thank you very, very much for watching.